India. So today I'll be covering part of agrometeorology as a tool. That is about the climate and weather, as well as a little part of weather elements that we will be discussing today. So before I directly start my lecture, I want to tell you that why this agrometeorology is important. So you will be studying in basic books like Reddy and Reddy or SR Reddy, that the importance of agrometeorology and everything. So, as we know that our country is mainly dependent on weather. Climate matters a lot for our agricultural activities, right? So, for farmers, it is very important to know about the weather or the climatic conditions, so what they are prevailing and how they are helpful for them. So, that is how it is really important for them to know. So, when it comes to understanding as an agricultural student, mainly this agrometeorology part is important for the students who are concentrating on agronomy JRF. When it comes to part of SRF, it is not included in the syllabus for SRF, but if you are pursuing masters in agrometeorology separately, I think then it will be helpful. As such, for SRF people, or maybe those who are students, those who are preparing for ICR net as well. I don't think this is important, because very less number of questions we can find in SRF or net. Hardly one or two questions will be asked, and that too will be kind of applied questions or maybe related to crops, like we can find in the question paper. And as the pattern of examination has been changed as of today, we have to concentrate on the concepts. So this I have already told you earlier as well, that the concepts matter a lot nowadays. It's not that we can mug up everything and we can go and write. No, it's not like that, like before. So it changes. It has been changed now, and it is quite a competitive type of exam. It is not so easy to crack JRF in today's time, right? So in that, agrometeorology plays a important part, because many conceptual based matters or the questions we can find in the JRF paper. All right, so why this agrometeorology? So we know that, as I told you, weather and climate are really important for farmers, and when it comes as a point of examination, then it really matters, because this is a kind of technical chapter we can find in our syllabus, because rest all the chapters, if we read it once or twice, it is very easily understandable. But this agrometeorology needs a little background of physics and little understanding, and understanding the concepts which are included in this. So it is a kind of technical type. So better we concentrate on the concepts, and we go slowly, those who are preparing for JRF. All right, so today we shall discuss about part of agrometeorology, that is about the weather and the climate, and a little part of weather elements like say humidity or the temperature, or the say solar radiation, which is of more important. So today we shall be discussing about that. So agrometeorology, as we know, it is meteorology is nothing but the study of the atmosphere. Right, so that is a study of lower atmosphere. Just a second. All right. So, study of lower atmosphere means the meteorology. Meteorology is a word which is derived from Greek word. So, meteorus means a lower atmosphere, and the logos means the science. So, study of lower atmosphere means the meteorology. And when you go for application or the different types of meteorology, you can find many systematic or dynamic type of meteorology. But we are more concerned about the agricultural meteorology. So I don't think you have to concentrate on the rest types of meteorology. I think this one will be sufficient for us to prepare for the examination. And what is climatology? So two words we will be learning here: meteorology and climatology. Climatology is the science which studies average condition of a weather or the state behavior of the atmosphere over a place or the region for a longer period of time. Whereas this meteorology, we study about the lower atmosphere and the weather related. But when it comes to climatology, it we study about the atmosphere over a larger area, and also it covers for a longer period of time, not just 1 hour or 2 hour. We study about, say, years together, 20 years or 30 years together, we will be studying about. So that is climatology. This climatology has derived from the word clima, which that is also a Greek word. You will find the words in many textbooks as well. So I'm just I haven't taken all those points into the slide. I'm just telling you. So climatology has been derived from a Greek word, that is clima. So that also states about the conditions or prevailing conditions of the atmosphere. So, and in that we usually talk about more about weather and climate. So we may get confused, like weather and climate. Even after being an agricultural graduate, if we cannot define properly what is a weather and what is a climate, then I don't think we really require that degree, because we mispronounce or misuse these words regularly. We may say that today's climate is really good weather, whereas we usually mean that today's weather is really good, right? So what is a weather and what is climate? So let's just have a comparison between a weather and climate, so it will be easy for you to remember the differentiation there. So weather is the instant state of atmosphere at a particular place. Say if you are at Rahuri right now, so in at Rahuri, what is the condition? How is the atmospheric condition? Whether it is sunny, whether it is rainy, or whether it is cloudy. So that's instant. At this particular time, what is the condition of atmosphere? So that is weather. Whereas the climate, it usually talks about the longer term average condition of a atmospheric condition. Okay, so say for example, take entire Maharashtra. So entire Maharashtra you can take, and then you can have an say some consolidated idea you can have about the climatic condition there. So larger area we are talking about, say for last 30 years, what has been the climatic condition or the atmospheric condition in Maharashtra. So that is climate. Weather is at this particular point, at this particular place, what is the atmospheric condition, right? And this weather, it can be expressed in terms of numerical values. We can say it in numbers. But in case of climate, what happens, we usually talk about the two terms here. One is time and the one is area. We do not mention it in numerical values, but we say for take for 20 years, 30 years, and we take for a larger area. So that's how area and time matters a lot in terms of climate. But in weather, it is an instant physical state, so it's not really necessary to mention and all. And in weather, we do not have any statistical treatment which is required or which is applied to meteorological elements. So what are these meteorological elements? Say rainfall, say clouds, or say atmospheric pressure or atmospheric temperature. So all these form the meteorological elements. So we usually do not apply any statistical treatment to know about them. So they are just observed and they keep changing. So we do not apply anything there. But in case of climate, what happens, we usually use the statistical method or the application to know or have a consolidated idea about it. Say for example, if you're talking about a rainfall for past 30 years in Rahuri itself, you take, so it may change, it may vary, right? One year you may have a better rain and the second year you may not be having a good rain, right? So that's how combining the rainfall for 30 years and applying the statistical method or the some tools to that, and to have a consolidated idea, we use this statistical method for a longer period. So these are the basic difference I wanted to tell you. And also what exactly this weather includes. So they include sunshine for a particular day, rain, cloud cover, wind, hail or snow, and rest all basic elements of weather we can include here. When it comes to climate, we usually talk about a larger area and for a longer period, right? So where we have precipitation, temperature, humidity, sunshine, wind velocity, but these all are consolidated, or it will be having an average data. So this weather is a real time data collection. right now at this place. But whereas climate, as I told you, it is the aggregation of weather data about say 30 years. So these are the basic differences you must be knowing. If at all you may find questions in JRF like what you say, assertion and the reason why it is so and what is the reason, and you will find many options for that. So in that this agrometeorology have tricky type of questions, so better you have a better knowledge of the concepts, not to mug up the things, not to by heart the things, just understand the concept, just try to solve as many as questions. I think then the concept will be perfect for you, and you can go for answering applied type of questions in the exam as well. Okay, so here you can see whether it can change within a few minutes or hours, right? So at this particular minute, it can be sunny. Maybe in the next few minutes, it can turn cloudy or rainy as well. But climate, it takes very long time to change. It cannot change immediately, just like weather. So here I have picture of rain, whereas climate, we talk about tropical climate. We do not say rainy climate or dry climate. We usually do not say that, right? We usually say like tropical climate, semi tropical or polar climate, like that we usually talk about the climate since it is for a longer period. So what are the weather elements we usually have? So weather elements means the normal things we usually notice, like temperature can be air and the soil, solar radiation which is of more importance, and then the humidity, right? Clouds, pressure, wind, and precipitation. So this precipitation involves all the different types of precipitation. Precipitation doesn't only mean the rainfall, it can be in the form of snow, it can be in the form of fog, mist, anything. The water from the cloud or the atmosphere we receive, that can be in any form, right? So precipitation doesn't only mean it has to be rainfall, it can be of any form. So temperature, what exactly the temperature? So these three factors I'll be discussing mainly. These rest all will be covered by some other speaker, I guess. So temperature, solar radiation, and humidity. You may just guess, just by looking at the terms you can guess why temperature or the air temperature is important, why solar radiation is important, how humidity is helping farmers. So we can relate everything very easily, right? So we shall talk about one by one about the factors, and then we can conclude it. Okay, so what are the different factors that will be affecting the climate? So now we know what is weather and what is climate. So what are the different factors that will be affecting the climate? One is latitude, altitude, land and water bodies, topography and vegetation. So latitude, you must have gone through the world map, right? You may find the equator, then the Tropic of Cancer and some other latitudes, and finally the northern polar. Similarly, on the southern side also we may find different latitudes. These are the horizontal imaginary lines on the world map we usually find. Okay, so these are latitudes. So based on the latitude also, we have differentiation of the climate. Say for example, at the equator, the climate is usually warm when compared to the polar. So we shall discuss why it is warm near the equator and why it is cool near the polar. Okay, and altitude is the vertical height we find. Say for example, this is the ground layer, and say this is a plant. So as we go upward in the atmosphere, so that is vertical upwardness we are going, right? So that is called as an altitude. And then how this land and water bodies will be affecting the climate. So land and water, these have specific heat, like exerting or say absorbing the heat and releasing the heat. So that we usually call it as a specific heat, and which differs, right? And then the topography. Topography is the landmass formation, how the topography is there. And then the vegetation. Vegetation, whether we have a greenery or whether we have a cactus kind of thing, how it is affecting the climate. So we shall study about them one by one. So first, the latitude. As I told you, latitude is the distance from the equator, either south or north, largely creates variation in the climate. As I told you, on the earth's surface, say for example, I'm just drawing roughly so that you understand it better. Okay, so this is equator, right? So equator, and then the Tropic of Cancer and some other latitudes will be there, horse latitudes, and finally the polar latitude, right? So from equator, as we go on the northern hemisphere or the southern hemisphere, we have different latitudes, right? So this equator is at about say 0 degree. 0 degree. So we usually find latitudes at a particular angle or degrees, right? So 0 degrees, and that's how they vary from one latitude to another latitude. And at 35 degree, we usually call it as a horse latitude. Similarly, on the southern side as well, we have horse latitudes or Tropic of Capricorn, and then the polar latitude on the southern side as well. So as we move say from equator upward or the downward, we find the difference in the latitude. Say for example, at the equator we usually have the warm type of climate. As we move upward or the downward from the equator towards the polar climate, the climate is really cool, cold climate we usually find, right? So polar climate, we know that when we say polar climate, we imagine something, the land completely covered by the snow or the ice, glaciers and all, we can imagine. So here at near the equator we call it as a tropical climate, and mid latitudes we call it as a subtropical, and then the nearby polar latitudes we have temperate, and finally the polar climate. So similarly on the southern side also it varies: tropical, subtropical, temperate and polar. So the plantation or the vegetation that grows on these different types of climates varies. The plant which grows in a tropical climate may not be growing in polar climate, cannot sustain itself, right? So the based on the latitude we can differentiate the climate here. Here you can see, so this is the equator, this is the Tropic of Cancer, Arctic Circle, and then the polar climate we find. Similarly on the southern side also you can find, and the our country is located, right? So this Tropic of Cancer is passing through the central part of India. So that's how it is divided. Our country can be divided, northern India and the southern India, we can say it likewise, right? So similarly here you can see the degree, 0 degrees, 30 degree north, 60 degree north, similarly. So between this, after this 35 degree north or the 35 degree south, we call it as a horse latitude. So that's how the what do you say, the climate varies there after. And the altitude is the vertical height, we can say. So from where we usually measure this altitude or the height? Usually from the mean sea level. So mean sea level is the level of sea, usually taken as a average, as an average we take it. So mean sea level, from that mean sea level, what is the height? Here in this picture you can see, this is the mean sea level, and what is the height of the mountain sitting over here, right? So this, even in the tropical region, the high mountains have temperate climate. So likewise in the latitudes we move towards the polar side, there we find temperature less, and that is of like polar climate, cold climate. Similarly when we go upward vertically, there also we find, whenever you go to hilly stations, you may find it is really cool when compared to the plain areas, right? So that is why, because the temperature also decreases when we move vertically upward in the atmosphere. That's how the latitude and the altitude affect the climatic condition here. And the temperature decreased by 1.8 degrees Celsius for every 300 meter from the sea level. So likewise we can imagine, you can imagine, if at all if you had been to Dehradun or Mussoorie, there you can find the difference in temperature when compared to the lower areas, right? So that's how the altitude and latitude matters. And coming to the land and water bodies, as I told you, land and water, this land mass and water mass, they have different specific heat. What is specific heat? Specific heat is something where the absorption of the heat by a particular so matter, or say a substance, we can say. When we compare this water and land usually heats faster and cools down faster than the water, because the specific heat of the land is less when compared to the water. Okay, so water has 1 gram per meter cube, like that, the specific heat, whereas the land, it is having quite lesser than the water. That's how there is difference. So water bodies moderate temperature and increases humidity, especially in coastal climate. So as the distance from the sea of a place increases, the differences between maximum and minimum temperature during day increases. So that is the temperature difference between the maximum and minimum temperature of a day. We call it as a diurnal temperature variation. So this difference is highest on the continental or the land station and lowest for the coastal station. So if at all you had been to coastal areas, you may find that day and night temperature doesn't vary much, because this water and land mass, they have difference in the heating, and the temperature usually remains constant near the coastal area. It doesn't change much. Maybe during daytime it can be 25 degrees Celsius, even during night also it can be little less, not much of difference we do not find there. So it can be of about say 23 degrees Celsius or 22 degrees Celsius, at the max 20 degrees Celsius. But when it comes to inner part other than the coastal area, so we may find during day we may find 30 degrees Celsius, but during night we may find like say 18 degrees Celsius or 90 degrees Celsius. So there is a vast difference, quite more difference between day and night, the diurnal variation in the land and nearby water bodies, right? So that's how these land and water bodies also affect the climatic condition. So the topography, as I told you, the land formation, how it is there. So the surface of landscape may be leveled or uneven. This produce marked change in the climate. It also affects the climatic condition. So this involves the altitude of the place, steepness of the slope, exposure of the slope to the light and wind, how it is actually. Say for example, if it is if the topography is something like hilly, like this, or say one more example, that is plain area you take. So the sunlight which is falling on the hilly area, it differs from the sunlight which is falling on the plain areas, right? So that's how this exposure to the sunlight, as well as what is the altitude, whether it is low or high, or say windy nature, so these all come under, we can include under topography to know the climatic condition of a particular place. Okay, and then the vegetation. So which kind of vegetation usually affect the climate? So this general type of vegetation present in a region which indicate the nature of climate, right? So thick vegetation is found in tropical region, right, near to the equator, whereas temperature and precipitation are high, right? So India is considered to be a tropical country, right? If we go to northern India, we may say that subtropical, or maybe sometimes a part of the country can be can be called as a temperate climate as well. So but most part of the country is of tropical in nature, where temperatures are usually high, and also the precipitation, right? So in that we find the vegetation. Say for example, in this picture you may find different diverse species of plants and trees are there, whereas in temperate we may find very less number of trees or the plants which can sustain in such type of environment, right? So this is the basic difference of vegetation that will be affecting the climatic condition of a particular place. So these are the different factors. Why I have explained the factors is because nowadays I find questions which are related to factors as well. They give some assertion and then the reason why it is so, like that. So that is why knowing about the factors and the details of those factors also really matter. So that's why I took these factors. All right. So now coming to the second part, that is Earth's atmosphere. So which is of very important, which is why we all are living well today, right? So the atmosphere is nothing but a thick gaseous envelope which surrounds the earth from all the sides and is attached to the earth's surface by gravitational force. So this thing I hope everybody knows, that atmosphere is a gaseous envelope. So what exactly this atmosphere is composed of? It is composed of gases, water vapor and particulate matter. So 99% of the atmosphere, we usually find two gases, right? Nitrogen and the oxygen. Remaining 1%, we find all other small gases, say like hydrogen, helium, xenon, so like that small gases we find, but most of the atmospheric gases are comprised with these two gases like nitrogen and oxygen. And apart from gases we have water vapor and particulate matter. So we shall discuss about those. So what is the average composition of the atmosphere? So this everybody knows, I hope. So nitrogen, which is of 78% in the atmosphere, oxygen is about 21% almost, and water vapor, it changes between 0 to 4% depending on the temperature. All right, argon and the carbon dioxide, so this is a old data, we can now say that it is almost say like 0.42 0.42 or 43% we can say carbon dioxide. And then the neon, xenon, you can see helium, hydrogen, you can find it with very less amount, less quantity in the atmosphere. So this in comparison to the soil, you have to know about the nitrogen and oxygen, where nitrogen is more, whether the atmosphere or the soil, where oxygen is more, whether atmosphere or soil. Similarly for every gas, better you know the content of these gases. Okay, so the second part is about the water vapor, and third is the particulate matter. So water vapor, we know that water vapor is nothing but the water molecules or gaseous form of water which is present in the atmosphere, right? So this vapor, as I told you, depends on the temperature. So it decreases from equator to poleward. So we know how it is actually differing from equator to poles, right? Similarly, I mean the climate also changes. Similarly, the water vapor content in the atmosphere also, it changes. It decreases from equator to poleward, the water vapor content. In tropical, we usually find more of humidity, but when compared to the temperate or poleward, if at all, if you go to northern India only, say if you had been to some extreme cold climatic places, say like Punjab, Haryana, Delhi and all, you may find it will be very cold when compared to the southern part of the country, right? Similarly, when we talk about the whole world or the world map itself, we can say that the water vapor content decreases from equator to poleward. So the content of vapor decreases upward as well. Just like the temperature, it also decreases vertically, water vapor. So more than 90% of the total atmospheric vapor is usually found within 5 km of the atmospheric height. So it helps in heating the earth's surface and lower portion of the atmosphere because it observes the terrestrial radiation. We shall discuss what is this terrestrial radiation, how it affects. Okay, so then the particulate matter. Particulate matter is nothing but the solid particles, say like dust particles, salts, pollen, smoke, volcanic ashes, or the other gases. So those all are suspended in the atmosphere. They do not move upward, or they do not land on the earth surface. They are suspended in the atmosphere. So because of this particulate matters, what happens, we can say that the solar radiation which is supposed to reach the earth's surface, or say for example the radiation which has to reach the atmosphere from the earth's surface, that will be diverted or say scattered like that. Okay, so you sometimes we may find question, why sky looks appear blue? So that is because of the selective scattering of the solar radiation by dust particles. And the salt particles, they become hygroscopic nuclei and thus help in the formation of water droplets and then the cloud, and finally they condense and they precipitate. So these salt particles, what happen? They become the hygroscopic nuclei. So what is hygroscopic nuclei? You can say that, for example, a salt particle which is present in the atmosphere, it attracts the water molecules towards it. Hygroscopic means it can absorb water or it can hold water, right? So it will absorb the water vapor and it becomes bigger, and it becomes a droplet, and finally the cloud, and finally it precipitates, right? So that's how the salt particles help. So you might have studied under this cloud seeding, we usually go for artificial rain making, right? So just like that, salt particles which are released into the atmosphere from different factories, they act as hygroscopic nuclei and thus they help in cloud formation as well. But apart from that, other particulate matters, they are not really helpful for the atmosphere, or say they also help in not really help, they affect the atmospheric conditions, say like greenhouse gases we have, right? So like that, that will increase the temperature of the earth's surface as well. So now coming to the different layers of the atmosphere. So the lower layers where the chemical composition of gases is uniform, we call it as a homosphere. So again, in homosphere and heterosphere we have different layers of atmosphere, say like troposphere, strato, meso, and the thermosphere. So, likewise, I'll show you a picture so you'll have a better idea about it. And at higher levels of atmosphere, the chemical composition changes drastically. We cannot have the same composition in the upper layers of the atmosphere, so it is called as a heterosphere. So here you can see this lower part is homosphere and this is heterosphere. So here you can see like a troposphere, strato, and then meso, thermo. So like that you can just say that up to mesosphere we have this homosphere, and the upper part of mesosphere, that we include under heterosphere, because the composition of atmosphere is not same. And above that we have exosphere. So we shall discuss about this in the subsequent slides. Okay, so now coming to the atmospheric layers. So now we know about the, excuse me, gaseous composition of the atmosphere and how they are affecting the climate as well. So when we talk about the atmosphere, these atmospheric layers are very important, right? So from the earth's surface we have four important layers, we can say. One is troposphere, strato, and the mesosphere, and finally the thermosphere. We can say about this, we have thermosphere. So you may find the different words like ionosphere and exosphere as well. These are nothing but the part of thermosphere only. So above the earth's surface, up to certain part, say some 18 to 20 kilometers, up to that altitude, we can say it is a troposphere. And there is one distinctive layer between troposphere and stratosphere, that we call it as a tropopause, or say stopping layer, we can say. And after stratosphere we have a thin layer. In the stratosphere only, ozone layer is also included here, so we call stratosphere as ozonosphere as well. So above the stratosphere we have meso and then the thermo. So how can you remember? Sometimes we get confused with the layers here. So you can say like TSMT. So you can make any of the words like that, and you can remember the consequent layers here. So troposphere, strato, meso, and then the thermosphere. So in thermosphere only we have part of thermosphere, I'm telling you, that is ionosphere, and one will be exosphere. Just a second. All right. So in thermosphere only, as I was telling you, so say for example, above the mesosphere, this entire layer is thermosphere. So the lower layer of the thermosphere, we can say it is ionosphere, and above the thermosphere we have the extra layer or the outside layer, we can say that is exosphere. Okay, so why this ionosphere? You must have read somewhere like they help in radio communication and all. That is right. And this exosphere, it includes hydrogen and helium as a part of its gases. So this division, it is mainly on the basis of vertical temperature, right? Tropostrato, meso, and the thermosphere. So what is troposphere? So the word is derived from a Greek word, that is vertical mixing. So here vertical mixing of air is predominant, and which is nearest to the earth's surface and has more or less uniform decrease in temperature with increase in height. So likewise, as I told you, TSMT you can remember. So for troposphere you can remember, as altitude increases or the height increases, the temperature decreases. Okay, and this is the region where weather phenomena is very well marked and described as weather making layer of the atmosphere. Most of the weather activities that happen in the troposphere only, they a part can be expected from the stratosphere, but most of the weather phenomena like say rainfall or the cloud formation, we can say, they take place in troposphere only. The top of the troposphere where there is decrease of temperature with height ceases, that is tropopause. As I told you, troposphere is marked with a decrease in temperature with increase in the altitude. So after troposphere we have a small layer or a thin layer, that is tropopause, where we do not find increase in decrease in temperature over there. So the height of tropopause varies from 16 kilometer over equator and 8 kilometer over poles. The average temperature of tropopause over the equator is minus 80 degree, while minus 40 degree over the poles. Right, this decrease in temperature with height, we call it as a lapse rate, 6.5 degrees Celsius per kilometer. That will be dropping, the temperature drop. So this is called as a normal lapse rate or the environmental lapse rate. Second layer is about the stratosphere. So this stratosphere, again we can say that lower and upper stratosphere. So in lower stratosphere, the temperature is constant with height, and this layer terminates at a height about 20 kilometer from the earth's surface. It is replaced by a layer where again there is increase in the temperature. So the second layer has increase in temperature, whereas the first layer, that is troposphere, it has a decrease in temperature, and the stratosphere has increase in temperature. So this increase in temperature, it extends up to say 50 kilometer, and this is temperature in this region more or less constant to start with, but it increases considerably gradually, and this increase in temperature is attributed, why actually this increase in temperature we can find is because of the absorption of UV radiation by the ozone layer which is present in the stratosphere. Okay, so that's why the temperature increase in stratosphere. So after the stratosphere we have again a thin layer, that is tropopause, and after tropopause stratopause, we have this mesosphere. Again the temperature here decreases, just like troposphere. We can find extreme drop of the temperature with increase in the altitude in mesosphere. So that is between 50 to 80 kilometers, and the temperature again decreases with height, as I told you. And this after the end of the mesosphere, we can find mesopause, and that is the coldest region in the atmosphere on the place, we can say, like nearly minus 95 degrees Celsius, 90 to 95 degrees Celsius. So at the height about say 80 kilometer above the earth's surface. So this is the coldest region on the earth's surface, that we can say, mesosphere. And finally the thermosphere, as I told you, you can imagine the thermosphere something like this. Within the thermosphere, as I told you, three parts we can have. The lower part we can have this ionosphere, and the middle part we can say thermosphere, and then the upper part of this we can call it as a exosphere, right? So again the temperature increases with altitude in this thermosphere. So the temperature in this thermosphere can be increased up to 1000 degrees Celsius. So as I told you, ionosphere, exosphere, heliosphere we can observe. So in this exosphere, this hydrogen and helium gases can be these are usually these molecules will be present in exosphere. So this can also be one of the question in your exam. Exosphere is made up of what are the gases? So hydrogen and helium are present in exosphere, and the lower layer of the thermosphere, that is ionosphere. This ionosphere helps for radio communication. So these radio waves are reflected in the ionosphere, where ultraviolet radiation split into nitrogen and oxygen and N2O. So likewise this ionosphere helps for this radio communication. So this is also an important for part of your examination. So now coming to the weather element, that is the atmospheric temperature or the temperature. So what exactly happens? As we know now that the near the equator, we usually have tropical climate, and towards the poles, it is a polar climate. So when we say about climatic condition, we talk about the temperature. Mainly, we include temperature as a factor there. So how actually it happens? See, whenever what happens, whenever there is receiving of solar radiation, the solar radiation will be received as a short waves, and these short waves will be the earth absorbs these short waves, and this absorbed heat can be reflected back as a long wave. Okay, just a second. Okay, warmest layer, we can say uh, stratosphere and thermosphere. Thermosphere we can say, but in text you will find stratosphere as the warmest layer. Okay, but thermosphere is usually warmest because the temperature is much more higher when compared to the stratosphere. All right, so these short waves will be converted to long waves, and these long waves will escape to the atmosphere. So that is how the solar radiation will be received and escaped. So that heat which is observed by the earth surface, that will leave as a long waves while heating the lower atmosphere. So the long waves which are escaping to the atmosphere, they will heat the lower atmosphere as well. So lower atmosphere means we can imagine troposphere. So the long waves which are going from the earth surface, we can say that this will be the long waves will be having heat. It will be containing heat, right? So while leaving the earth surface, they will heat the lower part of the troposphere as well. So likewise, we can say that when atmospheric the longer radiations or the long waves, when they increase the heat, or when they heat up the lower part of the atmosphere, so that heated atmosphere, what happens, that becomes a denser, not denser, it becomes lighter and it moves upward. So let me just explain a bit of it. Okay, so now we know that, say for example, so this is earth's atmosphere. I told you that the solar radiation that will be coming in the form of short waves, and from the earth's surface it has to leave as a longer waves. Okay, so longer waves, when it leaves the atmosphere, say here is our troposphere. Okay, so what happens when the heat reaches the tropospheric molecules, we can say the air becomes lighter. Because of the heat, it becomes lighter and it moves upward into the atmosphere. It moves more upward and it becomes lighter. Okay, because of the heat, and it expands and it becomes lighter. So likewise, when it move upward, by the time it move upward, the temperature here will be low when compared to the upper part of the atmosphere. So this you can find in atmospheric heating, why the atmosphere is heating, or we can say why the temperature is high at particular time, but whereas the solar radiation is more at particular time. So that I'll explain you. So because of this temperature variation, there is something called as diurnal variation. So that is the temperature difference between day and night. So the minimum air temperature occurs at about sunrise. So just before sunrise, we can say that minimum air temperature will be there, after which the temperature start rising. So the maximum air temperature is recorded between 1300 hours and 1400 hours. That is between 1 to 2 p.m. in the afternoon, whereas maximum solar radiation is at about 1200 hours, that is 12 o'clock. So at 12 o'clock we have higher solar radiation, but the temperature increase is at about 1 to 2 p.m. Why? This is why, because as I told you here, as I explained you here, the air parcel or the air mass, it becomes lighter. It becomes lighter and it moves upward. Since it moves upwards so slowly, the temperature will be less during that time. But at 12 o'clock, when solar radiation is there, we receive heat from the sun. but that heat has to escape into the atmosphere. It has to heat the atmosphere. It becomes lighter, it moves upward. When it becomes lighter and moves upward, then we feel more temperature or more heat. So that is the concept here. That is why the solar radiation is more at 12 o'clock, but the temperature is more at around 2 o'clock. So a steady fall in temperature till sunrise is noticed after attaining maximum. So in a day, we have maximum temperature as well as minimum temperature in a single day. So the difference between this maximum and minimum temperature in a day, we call it as a diurnal range of air temperature. So this diurnal change is more on clear days when compared to the cloudy days, right? Because of this cloudy days, what happens? The solar radiation will be diffused into the clouds, it can be reflected back, so we do not find much of the temperature difference in the cloudy days, but on clear days it is very much visible. We can find the difference in the temperature. This diurnal range of temperature is also influenced by soils and their coverage in addition to season as well. So just not the air temperature it is affecting, the soil temperature also matters a lot. So addition of daily maximum and minimum temperature divided by 2 is the daily mean or the average temperature. So you may find in weather forecast what is the mean temperature of today, tomorrow, like that you may find. That is the sorry. So that is, say for example, minimum temperature is 18 degrees Celsius and maximum is around say 32. So when we add these two and divide it by 2, we get a average, right? Excuse me. So this average temperature we usually give in terms of weather forecasting. So in northern hemisphere, winter minimum occurs, minimum temperature is in January, and in summer it is maximum in July. Temperature we usually find more and less. Okay, and this diurnal variation is mainly because of the vertical temperature difference. Now comes the horizontal air temperature distribution. So the lines connecting points of equal temperature horizontally, we call it as an isotherm, and it largely depends on the latitude. A general decrease in temperature from equator towards pole is one of the important factor for climatology, which we already know. So irregular distribution of land and water on Earth's surface, this breaks the latitudinal variation in temperature. Land areas warm and cool rapidly than water bodies. This I told you, that is because of the specific heat which differs from land of the water. Mountain barriers influence horizontal distribution of temperature by restricting the movement of air masses, as I told you about the hilly areas. And on local scale, topographic relief exerts an influence on temperature difference as well. So that is how the difference we can find. And this comes an important part, that is lapse rate. So what is a lapse rate? That is change in temperature or decrease in temperature when we move upward in the atmosphere or according to the altitude. That is about 6.5 degrees Celsius per kilometer. And now comes the adiabatic lapse rate. So adiabatic lapse rate is something, adiabatic process means which there is no external involvement of the heat, exchange of heat. Say for example, if a glass of water is boiling, okay, if it is boiling, only the changes between the molecules of the water matters, not the external heat. See, though we are giving this burner or the fire as an external source, this is just I'm giving an example. So the molecular activity inside the glass of water without any external exchange of heat, so that we call it as a adiabatic lapse rate. So now this adiabatic lapse rate, that is change in temperature when there is no exchange of heat with the surroundings, right? So that is constant for dry air, that is 10 degrees Celsius per kilometer, whereas for moist air we can say some 5 to 6 degrees Celsius per kilometer. So why actually there is difference between the adiabatic lapse rate of moist air and dry air? So here I have a picture, you can see here, this is the dry adiabatic lapse rate. So in dry adiabatic lapse rate, what happens? A small water vapor molecule, it moves upward, right? It becomes lighter and it moves upward, and the temperature difference also you can find only 10 degrees Celsius. They are slowly, not slowly, they are faster, they are releasing the heat and they are cooling down, right? So this you can see after certain point what happens, it becomes the change in the temperature gradually decreases. We do not find much of the difference in decrease in the temperature, right? So this is the difference we can find between the dry adiabatic and wet adiabatic right here. So, and one more thing that is related is about the temperature inversion. Here we usually say that as we move upward in the atmosphere, we usually find decrease in temperature, but in some cases what happens, there is inversion, that is where there is abrupt rise in temperature instead of fall of temperature in the air. So that we call it as a temperature inversion. So why it is so, why temperature usually inversion happens? So when the air near the ground cools off faster than the overlying areas because of heat loss during cooling nights. So during nights what happens, the, say for example this is the ground and the air which is near to the earth's surface, so this air mass what happens, it cools faster than the above overlying layers. So because of the faster cooling of this layer, we can find inversion, temperature inversion. Also when an actual warm layer passing over a lower cold area layer, say some from some other place, if the warmer air is moving over the colder layer, then we can say that that is also a part of reason for this inversion. Then cold air from hilltops and slopes tend to flow downward and replaced by warm air. So just you just remember that why it happens when there is a combination of warm air and cold air, when there is combination in a particular place, so then we can find this temperature inversion. All right, so why, what is the significance of this temperature inversion? So this helps in cloud formation, precipitation, atmospheric visibility are greatly influenced by this inversion. Also fog formation may take place near the ground because of the warm layer over the cold air, and diurnal temperature is affected. Also the incoming solar radiation and its conversion is also affected. Now coming to what is cardinal temperature. So for every crop or particular crop, we have a particular temperature requirement, say minimum temperature and optimum one and the maximum one. So minimum temperature is the one where we do not see any growth, which sees below which the growth ceases, right? So that is minimum. And optimum is the temperature at which we can see maximum plant growth at greatest maybe to a maximum extent. So that is an optimum temperature, and maximum is the one above which the growth ceases. So minimum and maximum, minimum is below which it ceases and maximum is above which it ceases. So optimum is the one which is required for any of the plant. So all three together, minimum, optimum and maximum, we call it as a cardinal temperature. So for tropical crops it varies, and for temperate crops that varies. So you will find the values of minimum, optimum and maximum temperature different, right? So in textbook you will find the temperature for this. And next part is this degree days, which is of very important. So a degree day or a heat unit or growing degree day, so which is very important. So this formula you must have seen, that is T maximum minus T minimum by 2 minus the base temperature. So base temperature is the one below which there is no growth of the plant. Okay, so this we call it as a threshold temperature. So the base temperature for kharif crop usually is between 10 to 12 degrees Celsius, and for rabi crops it is usually between 4 to 6 degrees Celsius. So that is the base temperature. And about a particular day, so what is the maximum temperature of that particular day and what is minimum temperature? So when we have the summation of say T maximum, that is maximum temperature minus minimum, divided by 2 divided by the base temperature, we get this growing degree days. So what exactly is this growing degree days? So it is nothing but the temperature that is required or that is present in a particular season or a particular day for plant growth. So that is, excuse me, yeah. So that is degree days. That can also be called as a heat unit or growing degree days. So why it is important? So this growing degree days, it helps in guiding agricultural operation and planting land use. So we can have, if we have an idea of about growing degree days, we can say whether we can take plowing today or not, whether it is, whether the temperature or the weather is suitable or not. So we can check that. It also helps in forecasting crop harvest dates, yield and quality, and in forecasting labor requirement also for agricultural operation, and introduction of new crops and new varieties, predicting the successful growth of a particular crop in an area. Other than this advantage, this growing degree days, it also has some disadvantages. So what is that? That is, growing degree days usually assumes a linear growth of a plant, but whereas we find the growth of the plant, we will find something like S type growth we find. No, it will be less, then it increases abruptly, then it decreases, right? That sigma type of growth we find. But this growing degree days, it usually assumes linear type of growth in plant, and also the base temperature, it assumes the same for the entire life cycle of a plant. Say for example, if the base temperature for rice, if we take it as a 10 degrees Celsius, for rice, for the entire season, say kharif rice is being grown, so it does not, we cannot say that the base temperature can remain as a 10 only for the entire season of the kharif, right? It can change today, it can change tomorrow. We cannot say that 10 degrees is the minimum below which we cannot see any growth. No, we cannot say that. We can find the difference in the temperature, base temperature as well. So these are two disadvantages of growing degree days. One is it assumes the linear growth of the plant, and one is it assumes the base temperature same for the entire season of any of the crops. So these two disadvantages also you have to note, because you may find questions related to this as well. All right. So because of this heat, maybe higher temperature or lower temperature, we will definitely have some disadvantages because of the temperature. So heat injuries means, one is we are having this thermal death point. Thermal death point is the temperature at which plants get killed. The temperature, maximum temperature, say 60 degrees Celsius, above which we do not find, I mean the growth won't be there, and the plant cells gets killed. So above 60 degrees Celsius, so that temperature at which plants get killed, that we call it as a thermal death point. So what happens when there is high temperature? It results in desiccation of plants, it disturbs the physiological activities, it increases the respiration to cope up with the transpiration process. And the another one is a sun scald. Sun scald, you can find injury on the plant because of the high temperature. And then the stem girdle, like girdling of the plant. I have picture here, you can see here. So this is stem girdle. Because of the high temperature also we can find in few cases. And this is some sun scald because of the high temperature here again, right? So these are because of the heat injuries. And now coming to the cold injuries. So just like we have injuries because of the high temperature, we can also have injuries because of less temperature. So you will usually find chilling injuries and freezing injuries. So chilling injuries when the temperature is less than 10 degrees Celsius, so that is chilling injuries. So here we can find injuries or the chlorotic conditions on the leaves we can find, so like that. But freezing injury is something when the temperature is less than 4 degrees Celsius, freezing. So what happens? Freezing means the water in the plant, it gets frozen, so because of that the plant cannot survive. So that is freezing injuries. And then the suffocation. Suffocation means in temperate regions, what happens in the winter season, a layer of snow will fall on the cover the ground surface, and because of which there will be difficulty in respiration, root respiration. So that's how that is called as suffocation. The plant cannot survive without oxygen in such condition. And then the last one is the heaving. So when we lift the plant along with the soil, a part of ice will also come up with the soil, that causes harm to the plant. So that also we find here. So you can see here, this is the chilling injury effect, and this is the freezing injury, and this is the suffocation part, and this is the heaving injury we can find. So these injuries also you can find there. So now what are the instruments we can use to measure the temperature? So the any layman can say that thermometer can be used to measure the temperature. So when it comes to observatory, agricultural meteorological observatory, then we have to know about something like Stevens sunscreen, which is having this maximum thermometer, minimum, and dry and wet bulb thermometer. So these four thermometers are embedded into this Stevenson screen. So this Stevenson screen in an observatory, it is usually north facing and it is white color faced. So this maximum temperature thermometer is placed in the upper groove, and the minimum thermometer is placed in the lower groove, and on the left side dry bulb, and on the right side it is wet bulb. So you should know the specification of this temperature as well, and when they are installed, and why these are installed. So you can expect question from this part as well. So this maximum thermometer is usually installed in the morning, and this minimum usually installed in the evening. And dry bulb and wet bulb, for wet bulb a muslin cloth will be covered on the thermometer to have a temperature stability there. Also we have this infrared thermometer where we can read the canopy temperature, right? So just like that you can find many different instruments to measure the temperature. I have taken very few because to explain everything it takes a lot of time. All right, so now coming to the global warming. So as we know, global warming is nothing but the increase in the temperature, right? So increase in the temperature, also escape of the gases. So here you can see we have different gases like carbon monoxide, carbon dioxide, CFCs, which escape into the atmosphere, and because of the dust particles which are present in the atmosphere, they absorb these gases. Okay, so when these gaseous particles or the dust particles, they absorb these gases, they heat up the earth's surface, because of which we are feeling more temperature. So the temperature has been increasing nowadays because of this carbon dioxide. Also carbon dioxide emission from rice fields and vehicles, refrigerators, factories, different petrols we are using. So because deforestation, all because of this, we have the increase in the concentration of the carbon dioxide, methane in the atmosphere, because and these gases are heating up the atmospheric earth's surface. So because of which the temperature increasing. So this is called as a global warming, or you can say greenhouse effect. Just like in greenhouse we find the heat is trapped inside the greenhouse, likewise we can say that the heat, because of these all gases, it is trapped in inside the atmosphere only, which is heating up the earth's surface. So this we can call it as a global warming, and because of global warming we can see this climate change and all. You might have gone through many articles, I hope, this global warming and the carbon credits and all. I'm not explaining much on this. Okay, so what happens because of this climate? So this increase in concentration of carbon dioxide and other gases, this increases the temperature. So because of, okay, yeah, because of this increase in temperature, there is effect on agriculture as well, and this crop production is weather dependent, and any change will have major effects, especially in our country. And this elevated carbon dioxide and temperature, it affects us many other biological processes as well. So can anybody tell me, is there any advantage because of this increase in carbon dioxide? Is there any advantage for any of the crops? Can anybody type and tell me? Anyone? Do you have any idea to which type of crop this carbon dioxide concentration is helpful? Photosynthesis may be increased. Okay, photosynthesis in what type of crop can be increased? Are you sure it is C4, Mansi?
No, I think, ma'am, that is carbon dioxide point in C4 plant is more. That's why I think.
Okay, what you told is right, but it usually happens for C3 because C3 plants it is helpful when compared to the C4 because in C3 plants what happens, the carbon dioxide compensation point is low, saturation point is low when compared to the C4 plant. So C4 plants even with a less amount of carbon dioxide they survive and they can pass their life cycle. But in C3 plant what happens, since the saturation is really high, even when there is higher concentration of carbon dioxide, they can take up the carbon dioxide and then they process. So for C3 plant it is helpful, but for C4 plants it is no much helpful because even with a small amount of carbon dioxide they can survive. That is one advantage we can have. So as of today, we can say that around the concentration of carbon dioxide is between 420 to 430 ppm, which was earlier 300 ppm. Now it has raised to 420 ppm. Now that is how the climate is changing, and that's how we can find higher temperature nowadays. All right. So the next one we'll be talking about is the solar radiation. So solar radiation, as we know from sun, as I told you, we receive short waves. Okay, so short waves and the earth leaves the uh, longer waves. So when sun is this we call it as an incoming solar radiation, or we can also call it as a, excuse me, insolation. So when we receive incoming solar radiation, not the entire amount of solar radiation will be absorbed by the earth's surface. What happens, part of solar radiation will be reflected back. So how it is reflected back? It can be reflected back because of the atmosphere, or maybe because of the clouds, or it can be because of the dust particles which are present in the atmosphere. So reflection is just touching those particles and moving back into the atmosphere. That is reflection. Okay, and part of the insolation that can be absorbed by the land and oceans also. Okay, so the reflected part of the uh, solar radiation, what happens, it will move back to the atmosphere. The incoming solar radiation which is received by the land and the ocean, that will be absorbed and later it will be escaping as a long waves. Okay, that the waves which are moving from the earth surface, we call them as a terrestrial. Terrestrial means the land. So terrestrial waves we call, or the terrestrial radiation we call. So you can remember incoming solar radiation. So the solar radiation which is directly reaching the earth surface, we call it as a direct solar radiation. All right, the solar radiation which is diffusing or which is passing through the dust particle or the atmosphere, that we call it as a diffused solar radiation or sky radiation. Okay, so direct is the one which is directly reaching the earth's surface. Diffused one is which is passing through the dust particles or maybe any particle which is present in the atmosphere, and then reaching the earth's surface. That we call it as a diffused radiation. So the combination of this direct and diffused. Okay, direct plus diffused, we call it as a global solar radiation. Please adjust, guys. I mean, with the mouse it is really difficult to write on the slide. Okay, so direct plus diffuse, we call it as a global solar radiation. So when we talk about direct and diffuse solar radiation, this diffuse solar radiation, it can also be called as a sky radiation. And when we compare direct and diffuse solar radiation, the amount of photosynthetically active solar radiation is much through the diffused solar radiation when compared to the direct solar radiation. We find hardly say around 35 percentage, we can say 35 to 40% we can say the direct solar radiation, that is of PAR, photosynthetically active. But in case of diffuse, we can say around 50 to 65% of solar radiation is photosynthetically active. So for any of the plant, obviously it is necessary that the light which is receiving, it should be photosynthetically active. So this diffused solar radiation is of much of work or much helpful when compared to the direct solar radiation. All right. So in between this direct and diffused solar radiation, the amount which is reflecting back to the atmosphere, we call it as an albedo, right? We'll talk about albedo later anyway. So this is how the usual process of solar radiation receiving and leaving the earth's surface that takes place. So what are the factors which are affecting the distribution here? One is the angle of incidence of the sun, and one is solar constant, one is duration of or the length of the day, and earth's distance from the sun, and the transparency of the atmosphere. So these are the factors which will be affecting. So the angle of incidence, see here, this say for example, if sun is somewhere here, the radiation which are reaching here, like short distance is there directly, which the part of the earth which is near to the sun, what happens, it receives more amount of, I mean short distance will be there, and more solar radiation will be reaching in a smaller area. But when sun rays are falling slanting on the slanting position or the crossed position, what happens, it has to travel a longer way, but that will be diffused or the directed to a larger area. So here we can say that intensity of the solar radiation is more on the smaller area when compared to the larger area, because the sun rays have to travel a longer distance in a slanting position, because of which the quality or the intensity of solar radiation that is supposed to reach the earth is less, but it is in a more larger area. So the angle of incidence also matters a lot, and that is why we see the difference in the equator and the polar climatic condition. Okay, second one is the solar constant. So you must have read it, right? Solar constant, what it is, it is nothing but the energy which is falling in 1 minute on a surface of 1 centimeter square. Say for example, this is earth and the atmosphere, this is the outer surface. Say just take 1 centimeter square area here, 1 centimeter square, something like this you can imagine. So on the outer boundary of the atmosphere, when sun is directly pointing the earth surface, okay, when it's held normal or perpendicular, when it is falling onto it, so that in 1 minute, what is the energy that is falling in that particular area, in that small area, in 1 minute, we call it as a solar constant, right? So that solar constant is about 1.94 calorie per centimeter square per minute, right? So earlier it was Langley, also it was used, the unit was Langley as well, but nowadays we usually consider this calorie only. So this also matters a lot, what is the energy that is falling onto the earth's surface. So here when it is directly falling onto here, onto perpendicular to the atmosphere, we can find more energy, but when it goes to a slanting position, then definitely the energy might be same, but it will be covering larger area, but what happens, the intensity of the sunlight will be reduced over there. And the third one is the duration or the length of the day. So heat received, it depends on the day or night or cloudy day, or whether it is a summer or winter. So when all the conditions are favorable, we can have higher or longer duration of sunshine we can receive. Okay, so on the autumn and spring equinox, equinox means day and night length will be same, that is September 23rd and March 21st, the sun is overhead at the equator, and we have equal amount of sunshine all over the world. Okay, equinox means day and night will be same all over the world, and we have solstice, summer solstice, and winter solstice, where day length varies, right? So that is also because of this one. And next factor is the earth distance from sun. So we know that earth is revolving around the sun in an elliptical orbit. So because of which, what happens, there is variation, seasonal variation we find, diurnal variation we find. So when earth and sun are very far to each other, so that we call it as a aphelion. Aphelion, that is on the July 4th, and in few textbook you will find that July 1st or July 2nd. is given when the distance between the earth and the sun is farthest, is more, that is about 152 million kilometer, that is called as an aphelion. When the earth is, or when the sun is nearest to the earth, that is say about 147 million kilometer, that we call it as a perihelion, that is on January 9. So when there is farthest, we can say, imagine that the solar radiation which is supposed to reach is less when compared to when the earth is near to the sun. So during aphelion, the northern hemisphere is facing the sun and it receives energy 7% less than the perihelion in the southern hemisphere. Perihelion, as we know, when it is nearest, even when it is nearest, okay, so when we compare the near and far distance between the earth and sun, the energy differentiation also we can find there. So do not worry much about this. You must know only about the terms like aphelion and perihelion. What does these mean? So here you can see that is January and July, and the perihelion and the aphelion, it has been given here. And the next factor is the transparency of the atmosphere. So transparency means whether any particles are present in the atmosphere, or any dust particles or any other particulate matters are present there or not. So when such particles are present, what happens? It leads to reflection, diffusion, absorption, scattering, or diffraction, or something like that. So transmission is something which moves through the particle. Reflection, as I told you, it will reflect back, the quality remains same. And the refraction is, it moves through one direction and it refracts, that means the direction of the ray, it changes. And then the diffraction is, it comes through a single ray and it diffracts into different rays there. And then the adsorption and absorption are two different words. Adsorption is the surface phenomenon, whereas absorption is the entire matter phenomenon. All right. And the scattering, so this scattering, because of the dust particle, we usually find the solar radiation will be scattered into different direction. So that is why we find this say blue color sky or orange color sky, that is because of this scattering only. Okay, so there are three different forms of energy transfer, that is conduction, convection, and radiation. All right, so I'll just explain through one picture here. So conduction is the movement of the molecule when we conduct, like if one molecule gets heated up, it will touch the another, it also get heated up, just like when we have a hot pan on the gas stove. You can see conduction is because of this water molecules, the pan gets heated up, because of the pan the handle gets heated up, when the handle gets heated up, when we touch it gets heated up, right? So connection will be there, so that is conduction. Okay, this process can be between solid, liquid. Okay, and the convection is between the liquid or gas in the same form of the same phase will be there. So convection is the movement of the molecule in the same phase, liquid only. So when they move from one place to another, they connect the heat, they conduct the heat. So that is convection. And the radiation, there is no medium for that, for this, no liquid or no gaseous medium. So it is just the electromagnetic radiation waves we can find. So that is radiation. So conduction is what? Energy transferred by direct contact from between molecules, and energy flows directly from warmer object to the cooler one, and can occur within one object, continues until object temperatures are equal. Okay. Convection, it occurs in gases and liquid, as I told you. Movement of large number of particles in the same direction will be there, and occurs due to differences in the density, and cycle occurs while temperature differences exist. So this radiation, these are the electromagnetic waves like light, microwaves, or infrared, and all objects radiate energy and they can transfer through the empty space, and they do not require any medium. They are just the waves. All right. So these three processes that takes place maybe in the atmosphere or maybe in the soil. So the first part, I mean heating of the atmosphere, when it happens, so from the earth surface, to certain point of atmosphere, that is conduction, and then the convection, and then the radiation will be there. Similarly, in the lower layers of the soil also we can expect the say from soil surface to a certain point we can have conduction, thereafter convection, and then the radiation we can have. So these are the three forms we usually find. Okay, when it comes to solar radiation, that means we are talking about the radiation and not about the convection or the conduction here. So when it comes as a electromagnetic radiation, what happens? They usually come in terms of bands. Okay, so this broad band of wavelength will be there, so that we call it as a solar spectrum, and also it is also called as an electromagnetic spectrum. So this does not constitute only one band, it has multiple bands, right? You might be knowing about the gamma rays, UV rays, visible light, infrared. So that is the solar spectrum I'm talking about. Say here, you can see short waves. Okay, short waves and long waves, in between we have this visible light. Okay, so before 300 nanometer we can have the short waves like gamma rays, UV rays, X rays. Okay, and between this 380 or 400 to 700 we have the visible light, which is of much importance to us and also for the plant. So again, in this visible light we have something like a color called as Vibgyor, right? Violet, indigo, blue, green, yellow, orange and red. Likewise, so before Vibgyor or the visible light we have short waves. After Vibgyor we call it as a infrared. So when it is near to the visible light we call it as a near infrared. Alright, so this infrared have a longer wavelength when compared to this, and this UV rays are absorbed by the ozone layer, and these short waves are not reaching the earth surface, be it x-rays or gamma rays, they are not reaching the earth surface and they are really harmful. So that's how the ozone layer is protecting us, and this Vibgyor is very important when it comes to photosynthesis point of view. All right, so this solar radiation, this shorter than the visible light, that is we have this UV rays or the X-rays, these are chemically very active, and when plants are exposed to this radiation, effects are detrimental. We cannot expect any good result from this short wave exposure. All right, atmosphere acts as a regulator for this radiation, and none of the cosmic gamma and X-rays reaches to the earth, this we know, and UV rays of this segment reaching to the earth are very low and is normally tolerated by the plant. Again, in UV rays you may find UVA rays, UVB rays and UVC rays, okay, with different wavelengths. All right, next is the higher than the visible, that is the infrared radiation. So it has thermal effect. Thermal effect means say like thermal death or increasing the temperature, heating type of effect it will be having. So in presence of water vapor, this radiation does not harm a plant since water is present adequately, but it supplies thermal energy. In absence of water vapor, we can say that there will be some harm to the plant. Alright, and the visible spectrum, that is between the UV and infrared, that is also called as a light or the visible light. So these are directly or indirectly influenced by the light. So you may find whether the opening of the leaf, which light is helping, blue light or say red light, or germination of the seed, so which light will be helping. So all those light come under this spectrum only, visible spectrum only. Okay, so the intensity, quality and duration is very important for normal growth. So when we talk about the direction, again we talk about the day length, like a short day, long day and all. Poor light leads to plant abnormalities, and light is obviously indispensable to photosynthesis. Photosynthesis cannot occur in absence of light. So it affects all the physiological aspects of the plant here. So the next term is the albedo. Albedo is nothing but the reflection. So how much radiation is being reflected by a particular matter or particular thing, we can say. So it is defined as the ratio between reflected radiation to the incident radiation on a crop field. Say for example, here 100% excuse me, yeah. So when 100% of light is being received by a particular thing here, it is reflecting back 80%. Okay, so that means we say give me a minute. sorry. Yeah. So here most of the light which is absorbed by a particular thing, that is being reflected here. So that means we call it as a high albedo. Alright. In case of black body, you can see 100% it is absorbing, but it is reflecting only 10%. Only 10% is being reflected, right? That means low albedo. Right? That means low reflection is there. So white bodies usually albedo is more when compared to the black body. So you can find for dry soil, wet soil, dark cultivated soil, or human skin, water, cloud. So it varies. The albedo or the reflectivity varies. Alright. And coming to the instruments to measure the solar radiation, we have sunshine recorder, which have 3 grooves, where we can insert different cards, short cards or medium cards and the long cards according to the seasons we have. Then the lux meter, we have quantum sensor for to measure the photosynthetically active radiation. And this pyrheliometer, it usually measures the net radiation, and pyranometer, which measures the incoming solar radiation. So likewise you can find many different instruments which measure the solar radiation here. So now coming to the next factor, that is humidity. So as we all know, humidity is nothing but the amount of water vapor which is present in the atmosphere. So how it happens, when the water molecule or water evaporates from the earth's surface or from the water bodies, that will condense in the atmosphere, that will become a cloud, and that will come back as a rain, right? So when it condenses, maybe because of the temperature variation or the amount of water vapor, when we compare with the other saturated body, then we call it as a humidity. So there are 3 types of humidities we usually study. One is absolute. Absolute means a particular amount of water vapor will be there. That is the actual amount we find in the atmosphere. So it is nothing but the weight of water vapor to the volume. So we are talking here about the weight by volume, weight of the water vapor to the volume of the air. Okay, so this is expressed in terms of kg per meter cube. So this absolute humidity, it differs from place to place. Since I told you that it is an absolute humidity, it does not mean that it has to remain same for all the places. It can differ from place to place. Okay, and the ability of the air to hold the water vapor depends entirely on its temperature. So can anybody tell me when humidity will be more, whether the when temperature is higher or lower? When do you think the humidity will be more? In which condition? Can anybody type and let me know? Okay.
Nobody willing to reply.
Yeah, that's okay, sir. All right. In high temperature, right? So in high temperature, no dear. When temperature will be low, no, we do not find higher humidity. In high temperature, we usually find more humidity. That is because, see, in atmosphere, what happens? Say for example, if these are the places where water vapor can be included in the atmosphere, so when high temperature is there, more of evaporation and transpiration will be there. So when evaporation and transpiration will be more, what happens? The water which is escaping through this uh, parts or the space which is available in the atmosphere, that will also escape because of the high temperature. So because of which continuous cycle of accumulation of water vapor will be there. So that is why we usually find humidity more in this higher temperature than the lower temperature area. All right. So next term, one more thing you have to remember here is about the unit. So this absolute humidity is about weight by volume. So it can be gram per meter cube, or gram per centimeter cube, or kg per meter cube. And next is the relative humidity. Relative means when we compare something with another thing. Say for example, if here you can see when temperature is low, that means relative humidity is more. Relative means we tell in relation to the saturation of the atmosphere. Saturation means when all the spaces which is available in the atmosphere is completely filled with the water vapor, we call it as a saturation. All right. So when we compare something with the saturation, say for example, if 100 spaces are there, small, say small holes are available, that is 100 small holes are available in the atmosphere. Only 60 holes are completely filled with water vapor there, and remaining 40 it is not filled. So we can say that 60 out of 100, that is in relation to the saturation we are telling, right? So that is relative humidity. So that is actual amount of humidity present in the atmosphere when compared to the saturated humidity. So that is the actual ratio of actual vapor pressure to the saturated pressure, which is expressed in terms of percentage. Relative humidity you may find while studying for different crops also, you will see relative humidity should be 80% or 70%. What does that mean? Out of 100%, 70% of the atmosphere should be filled with atmosphere. So that is the meaning. So percentage of moisture present in the atmosphere as compared to its full capacity. So as the temperature increases, the capacity to hold moisture also increases. Here you can see this yellow part is the capacity to hold the water vapor. All right. So as the temperature increases, the capacity to hold the moisture also increases. That is why in higher temperature area we can say that more humidity will be there. Say for example, go to any coastal areas, you will feel so hot there. You will also feel very sweaty there, right? So that is because of the combination of temperature and the humidity. All right. So this humidity can be changed by adding moisture through evaporation. So how can we change this? So when evaporation increases, then the amount of water vapor which is supposed to be present in the atmosphere, that will increase, and that's how the relative humidity we can change there. And by changing the temperature, so same just like the previous one as I told you. So when temperature increases, then the saturation point increases, and thereafter the relative humidity can also be increased likewise. And there after relative humidity comes the dew point, which is very much of importance. So what happens, we now know the saturation means when entire atmosphere, or say when there is no space available for water molecules to sustain or be present in the atmosphere, when it is completely filled and the atmosphere cannot take any more water vapor, when such condition is there, that time or at that particular temperature we call it as a dew point. Okay, so the air at a given temperature is incapable of holding any additional amount of moisture at that particular stage, and that we call it as a dew point. So this is the point where cloud formation occurs, where this is where condensation occurs, this is when the precipitation also we can expect. So what when exactly this dew point will be there? Obviously when relative humidity is 100%, that is the temperature at which we can say that dew point is there, it has achieved dew point. All right. And next is the specific humidity. So this specific humidity we usually talk about, say the unit is gram per kg, that is mass by mass we usually take here. So mass of water vapor in a sample of moist air to the total mass of the sample. So it is expressed in kg of water vapor in a kg of moist air. So this specific humidity is not affected by changes in pressure or the temperature, whereas absolute and relative humidity, they are affected by the temperature or the pressure difference, whereas the specific humidity does not change. Okay, so specific humidity we can say it as a constant. Also we can call it as an unitless, since these are of same units here, we can say that it is what you say, it can be a unitless. So what are the instruments we usually use to measure the this humidity? Psychrometers, hair hygrometer, Assman psychrometer to measure the canopy's relative humidity. So this psychrometer is usually combines 4 thermometers, as I told you, like wet bulb and dry bulb, and also these two will be there, and also maximum and minimum thermometer, which is included in that Stevenson screen to measure the temperature. So like that you can find many instruments for temperature. And finally coming to the last part of today's lecture, that is weather forecasting. So weather forecasting, we know that telling about the future weather, how it is affecting, or what might be the probable weather, maybe tomorrow or day after tomorrow, so that farmers can be helpful for with that, right? If a farmer doesn't know what will be the weather tomorrow, how can he take up any of his field operations, right? So this advanced information about the weather, probable weather, which is obtained by evaluating the present and past meteorological condition, we call it as a weather forecasting. So how it is actually helpful? Weather forecasting, it helps in agriculture, including forestry and animal husbandry. We know that agriculture is wider sector where this weather forecasting helps, and obviously for this shipping, mercantile and naval operations, offshore drilling, defense services, aviation, government and post officials, cyclones, floods and drought, mountaineering, fishing, general public. So for everybody is in need of this, right? So we cannot take up of any of our operations without the knowledge of this weather. So this weather forecasting services has a wider or broader area of operation where it can operate. So there are 3 or 4 types of weather forecasting classification based on the duration they give. So the classification is given by IMD, India Meteorological Department. Okay, so 4 types we usually say. That is nowcasting, that is less than the 12 hours. I mean the data will be given about say within 12 hours. So it can be related to thunderstorms, dust storms, cyclones, cold and heat waves. So nowcasting is also helpful for outdoor functions also. And then comes the short range. Short range is between 72 hours or say 3 days. Up to 3 days we can get the data. That is short range. And these are issued twice a day. In a day it can be issued for 2 times. All right. And next one is medium range forecasting, that is between 3 to 10 days the data will be given. And long range in between, that is more than 10 days, up to a month or maybe up to sometimes a season can also be the data can be given. But Indian monsoon is something like gambling, we cannot expect anything today or tomorrow. Even after such a advancement in weather forecasting, then also our country fails sometimes to predict the weather, right? So we cannot say about the monsoon, but this is how the classification goes there. And what are the tools usually used for weather forecasting? There are 2 tools we usually use. One is synoptic chart, which gives the symbols and what is the condition. Even if you Google or weather, if you update weather on your phone, you will see whether the cloud picture it will show, whether the rainy picture it will show, or the sunny picture it will show, right? So such kind of charts we call them as synoptic chart. So they display weather condition at a specific period over a larger area. Okay, so what are the different conditions that are being used there? So narrow black lines means isobars, that means equal lines of pressure, atmospheric pressure, and numbers at the end of isobar means pressure value will be given there. And if a shade is there means precipitation, it can be rain, it can be snow, or it can be anything. Arrows means it tells about the wind direction. Feathers in the arrows means it tells about the wind velocity. Small circles with shading means amount of the clouds. Alright, so this is a small example I am showing you here. So these are the different symbols which are used to show the weather forecasting. Alright, so here also the entire country tells how it is done, or this is how the weather picture we can say it is given. Okay, so this is synoptic chart. And second is the weather calendar. It gives information about weather to the farmers. So this weather calendar, it usually has 3 parts. Alright, so I'll just show you here. Okay, so this you can see, this is a weather calendar. So the upper part, 3 parts will be there. Upper part, middle part, and the bottom part we can say. So this upper part, it tells about the months and what is expected. Okay, during those season. And the middle part tells about what are the requirement of particular weather elements during that growing season. Say for phenological stages will be given, say like emergence, seeding, tillering given, and what is the temperature maximum, minimum, relative humidity, wind speed, rain, evaporation. So everything it is given in the middle part. And the bottom part, it tells about the different pests and diseases that might be attacking, or it tell about the other disasters that may happen in the prevailing season also. So it tells what are the conditions that will help or initiate the disease or the pest for that particular season. So a farmer must be knowing about how to interpret this weather calendar. Our farmers are not well aware of how to interpret this calendar and all. So if you ever meet any of farmers nearby, try to help them to how to interpret this weather calendar. Every state issues, every agricultural university issues this weather calendar. So better if you can interpret this really well, I think you can help the farmers nearby as well. All right. So the next one, there are different methods of weather forecasting. One is synoptic method. Synoptic method means over a larger area and using those symbols and using the previous data and the present data, they will predict the future data. So that is synoptic one. They'll prepare the chart, and this is synoptic one is mainly used for say short range type of forecasting. All right. And next one is the statistical method, where they use multiple regression, just like one model, that is ARIMA, auto regression model, it is there. So this can also be used. Various regression models are being installed into the software and they are being interpreted likewise. So this statistical, this is helpful for say short and long range type of forecasting. And third one is the numerical weather prediction. Here we have equations, different numerical equations we have based on the all the weather elements, and that will be interpreted. That's how model will be prepared and that will be interpreted. So this numerical weather prediction, this is mainly meant for the medium range forecasting. So that is how the different methods are used for different types of weather forecasting. All right. So that was all about my topic as of today. Thank you, sir. Thank you for this opportunity. If you have any doubts or any clarification, you are free to ask.
Participants, if you have any query, you can ask.
Any doubts or anything you did not understand, you are free to ask.
Hello.
Yes.
Hello. Ma'am, can you please explain again the solstice and equinox again? There is so much confusion.
Okay, see, equinox means it is something, the day and the night length will be same. Okay, that is equinox. So equinox, when it will happen is when the sun usually comes on the equator usually. So that time we have the equinoxes, day length and the night length will be same. So we in a year we find 2 times equinoxes, 2 times. One is on the March 21st, that is one equinox, and another we find on the September 23rd. That is because of the movement or the revolvement of the earth's surface. Just a second, guys. So that is because of the movement of the earth around the sun. That is why we find the difference in the day length. Okay, so when you move from say from March till September, again we can say that the day length it increases. Okay, but after September we say that day length decreases and the night length increases. So that is all because of the revolvement. So equinox is nothing but the equal length of day and night. Is that clear?
Yes, ma'am. Thank you.
Okay. Any other questions you have?
Okay, I think there are no any questions. Mr. Nana Sahib, are you there?
Yes.
Okay, please conclude the session.
Okay. We are very much thankful to ma'am on behalf of so that is then weather elements like temperature, temperature of year and such, then solar humidity, then pressure, wind, and perspective like altitude, latitude, land and water bodies, then topography, vegetation. Then you reach the layers of atmosphere, atmosphere like troposphere, stratosphere, mesosphere, and thermosphere.
Mr. Nana Sahib, I think your voice is break. Thank you, ma'am, for your very nice lecture on particular agrometeorology.
Thank you,
You are
sir.
very well pleased with your nice presentations and skills. So everybody very eager to heard you. Thank you, sir. Thank you,
Thank you,
ma'am.
sir. Thank you.
Okay.
I hope this was helpful. Thank you, sir.
Definitely, definitely. Good day.
Thank you, sir. Thank you, everyone.
Okay, we will end here. We will meet all the participants in the evening session. Thank you.
Thank you, sir.
Okay. Nana. Hello. Hello, Nana Sahib. Are you there? Please end the meeting.